This is our third attempt to look at 1/8. We're now looking at rational inequalities. We first looked at polynomials in 1/8, then we looked at something else. I forgot what it was. Now we're looking at rational. Rational means every time I ask this question, I get blank looks like, what are you talking about? Fractions. Okay, so we have a polynomial in the numerator, we have a polynomial in the denominator. Makes it a rational, but now we're talking about inequalities instead of equations. We're going to talk about key numbers again. Remember, key numbers happen when the denominator is 0. Key numbers happen when the numerator is 0. So that's what we're looking for on these problems as well. So it says the concept of key numbers and test intervals can be extended to rational inequalities. Use the fact that the value of rational expressions can change sign only at its zeros, the x values for which the numerator is 0, and the undefined values, those are the x values that make the denominator 0. So again, where the numerator is a 0, where the denominator is a 0, those are your key numbers. These two types of numbers make up the key numbers of rational inequality. When solving a rational inequality, begin by writing the inequality in general form. What does general form mean? You get everything on one side and a 0 on the other. Okay? If you have a 0 on the right side, and with everything else on the left side, that's going to be general form. Okay? So put it in general form with the rational expression on the left and the 0 on the right. So here's a problem. I didn't cover anything up. I'm just going to kind of talk through this. The problem given to you is 2x minus 7 over x minus 5 is less than or equal to 3. Step number 1, put it in general form, which means subtract 3 from both sides, right? So once we subtract 3 from both sides, then I've got a fraction and a number that's not a fraction. Sometimes you'll have two fractions. How do you combine two fractions? What must be true? Common denominator. Well, the same is true here, even though 3 is not a fraction, unless you want to say it's 3 over 1. Okay? So in order to combine 2x minus 7 over x minus 5 minus 3, I've got to find a common denominator. What is my common denominator? There's only one, so it better be the common denominator. X minus 5 is the common denominator. Okay? 3 does not have an x minus 5 in the denominator. How do I make it have one? Do what? Okay. If I want to turn 3 into a fraction that has x minus 5 in the denominator, what do I do? What can you multiply by that does not change the value? 1. What is the 1 that I'm going to use to multiply 3 by? That's not 1. You'll act like I've lost my mind. How about x minus 5 over x minus 5? Is that 1? Yes. Will that give me a denominator of x minus 5? Yes. So on the top, that 3 is going to have to be distributed, right? And because this is a negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15. So that's where the negative 3x plus 15 came from. Okay? Now that that's in place and they both have a denominator of x minus 5, I can write this as one fraction. Questions on that? You need to put your book up. Okay. Okay, now that I've got a common denominator, I have a numerator that's messy. I need to clean it up, combine like terms, and I get negative negative x plus 8 over x minus 5 is less than or equal to 0. What are my key numbers? What makes the numerator 0? 8. What makes the denominator 0? Those are my key numbers. So I'm going to take that infinite number line and I'm going to break it at 5 and at 8. Okay. So the key numbers are 5 and 8. So my test intervals go from negative infinity to 5, 5 to 8, and 8 to infinity. Those are my test intervals. What do I do with test intervals? You choose a number, right? Any number in that interval and plug it in. So if we choose x equals 4, plug a 4 into this, we get negative 4 plus 8. Negative 4 plus 8 is 4. 4 minus 5 is negative 1. So I have a positive divided by negative, which is going to be negative. Is a negative number less than 0? Yes. That's why this area right here is shaded. Because if 4 works, then any number from 5 to negative infinity is going to work. Notice there's parentheses around these test intervals. There's parentheses around test intervals because you don't want to use the n numbers for testing. Okay? Choose a number between 5 and 8. They chose 6. Negative 6 plus 8 is negative 2. 6 minus 5 is 1. Okay. 2 is positive. 2 is greater than 0. Does not satisfy, so this area is not shaded. Choose a number greater than 8. They chose 9. Negative 9 plus 8. Negative 1. 9 minus 5. 4. Is that positive or negative? Negative, so that's shaded. Okay. The test intervals are always parentheses. The answers might not be. Looking at this equation here, can x be 5? Can x be 5? No, because can't divide by 0. Can x be 8? Yes, because I can have 0 on the top. So because x can be 8, notice there's a bracket here instead of a parenthesis. Okay, so again, on the intervals, it's always parentheses because you never want to test your key numbers into the equation. Okay. On your answer, pay attention. Can it be that number or not? Because now we're giving the intervals of the answer. And that's also mentioned on the next slide. I'm moving forward. Because negative x plus 8 divided by x minus 5 equals 0 and x equals 8, you can conclude that the solution set consists of all known numbers on the intervals negative infinity to 5 union 8 to infinity. 8 is included because the top can be 0. Questions on that problem? All right. As far as these problems go, 1 is very straightforward. 2 is just like the example we looked at. I do want to go ahead and work number 4. Let me get to 4. There it is. Okay. Rational inequality. Step number 1. What do I do? Not yet. General form. General form. So how do I put this in general form? Okay. I'm going to subtract this guy from both sides. Perfect. 2 over x plus 5 minus 1 over x minus 3 is greater than 0. And if you want, right now we're looking for those key numbers. We're wanting to know what the key numbers are. If you want to change this to an equal sign, that's fine. It doesn't matter right now. Just go back to the original problem when you're doing your test numbers, okay? Common denominator. What is it? I need to find it. What is it? Tell me by looking at it. No? Okay. Common denominator. Why? Okay. So what you're telling me then is I need to make this guy turn into a 6. How do I make that 2 turn into a 6? But to be legal, I've got to do the top and the bottom, right? How do I make this guy a 6? So to make it legal, right? Folks, that's kind of what this is here. Okay. Notice that 2 over x plus 5, the denominator is x plus 5. It has an x plus 5. The other one has a denominator of x minus 3. The one on the left needs to have an x minus 3, doesn't it? So I'm going to multiply this first one by x minus 3 over x minus 3. What does this one need? And I'm going to go ahead and just change this to an equal sign because right now, again, I'm just looking for the key numbers. So I really don't care about the equal or greater than right now. I'll worry about that in a little bit. Okay, we need to simplify this. Recommendation is to leave the bottom alone at first. In fact, just leave the bottom alone because we're looking for the key numbers and we're going to want it factored anyway. On the top left side, what do I have? X minus 3 times 2. 2x minus 6. On the other side, what do I have? Negative x minus 5. Okay. It might be useful to you to go ahead and change that to a plus and move that negative sign to the top. Okay, because now we're clearly combining 2 fractions with a common denominator. Okay, denominator is what? Do not multiply it. Don't multiply it. That's not multiplying it right anyway. Yeah, leave it alone. Because it's factored, I already know what x can't be on the bottom. Don't you know? On the bottom, what can x not be? 3, negative 5. That's 2 of our key numbers right there. Okay, so don't multiply it out. Leave it alone. Top, what can I do to that? Do what? You factor the top? Teach me. What's Sean say? Combine like terms. Okay. So 2x minus x is x minus 6 minus 5 over x minus 3 times x plus 5 equals 0. Key numbers. Okay, 3, negative 5, and if I put those in order, what makes it 0? 11 minus 11 is 0.
specific way that we'll have to list the key numbers, like numerators, key numbers, or denominators?
No, because the key numbers are going to break up that infinite number line to give us our test regions. So what are my test regions?
Negative infinity to -5.
-5, comma, -5 to 3, comma, 3 to 11. Okay. Which means I need to choose 4 numbers to plug into the original. Okay. And I want the left side to be bigger than the right side. So a number between negative infinity to -5.
Yeah, that's what I said.
-6. Okay, so if we plug the -6 in there, that would be 2 over -1 is greater than 1 over -9. -2 is greater than -1/9. -2 is greater than 1/9. That is false. Okay, a number between -5 and 3. Okay, so I've got 2 over 5 is greater than 1 over -3.
Yes.
Okay, true. A number between 3 and 11. 10, okay. 2 over 15 is greater than 1 over 7. 2/15 is greater than 1/7. 1/7 is the same as 2/14. 2 over 15 is greater than 1/7.
Oh, I thought that was the same.
I've got trues and false all over the place. Type in your calculator. 2 over 15, enter, get a decimal value. 1 over 7, get a decimal value. What's 2 over 15? 0.133. 1 over 7. Which one's bigger? 1/7 is bigger, so this is false. Number between 11 and infinity?
33.
I'm going to go 12. 2 over 17 is greater than 1 over 9. 2 over 17 is bigger. So this is true. Okay. Do we have any equal sign in our original problem? No. So our answer is going to be parentheses only. Okay. Final answer. Where is this true? Small to large.
3.
It's true here, right? And true here. So final answer. -5 to 3 union 11 to infinity. Okay. And I'll go ahead and go to the next slide. So there were 4 problems, I only worked 1 of them. But there's the answers to all 4 of them. Okay. And folks, that's it for 1/8C.